Hello, everyone. So the concept for this section is the difference quotient, and the difference quotient is a fancy term for being able to find slope on something that's not a line. Where I want to start you guys with is going back and looking at the definition for slope on a line. So you got your rise over your run. The formal math equation looking thing that you guys have been using is y1 minus y2 over x1 minus x2. I suppose technically I should back up and go, it's y2 minus y1 over x2 minus x1. In the math realm, it really doesn't matter. When you're doing physics, yeah, it does matter, but you know, we're being a little loose with the terminology here. So rise over run. That's what you guys need to get out of this. And that you had a formula that did it. So if I wanted to find the slope on this line, I would first need to find those two coordinates. So negative 2, 5. And that looks like 4, 7. And then take the y values, find the difference. So, whoops, I don't know, I did a parenthesis there. I apologize. I'm setting up this fraction here. So we'd have 7 minus 5 over 4 minus a negative 2. So the slope between those two lines would be 2/6 or 1/3. Now you can also get that by counting. If I were to count up to that level over 1, 2, 3, 4, 5, 6, I still get a third. So it's the idea of rise over run, right? It's a basic definition of slope. You should also notice that any line that's going to run this direction has a positive slope. So that's something that you guys need to have in your head, that any line that goes up to the right is going to have a positive slope. And by doing this one, if we don't do the formula, just do this definition, I'm going to drop 1, 2, 3, so I go down 3. So down 3 over 1, 2, 3, 4, 5 over 5. So I ran 5. That's the slope, negative 5/3. So any line that goes down to the right is going to have a negative slope. Those are two basic concepts that you guys definitely need to walk away with and have stored in your heads. Okay, from way back in Algebra 1. Anything that goes up to the right is a positive slope. Anything that goes down to the right is a negative slope. It goes down, it's falling. Okay. This definition is good when you're finding slope on a line. When you know 2 points, this works well. You've got 2 points, you can do it. But the question I need to push you with is, what if you only have 1 point? Now you may ask, how do you have a line with only 1 point? That's one of the things we're going to talk about. Also, positive and negative slopes. Which way do they run? Well, we did that. Anything that goes down is a negative slope. Anything that goes up is a positive slope. So, what if you have slope on a curve? And that's where we're going to start looking, is things that are other than lines. What you should notice from this is the slope is always changing. How do I know that? Well, if it's constant, if your slope is always the same, you have a line. If it isn't a line, then the slope is never constant. The slope is always changing. The slope here is different than the slope there, is different than the slope here. If for no other reason, we talked about things that have a positive slope and a negative slope. Anything that has a positive slope is going up. So let's say I use these 2 points here and find the slope between them. Isn't that going up? Well, what about these 2 points? Isn't this going down? This side of the graph is all going to have negative slopes. This side of the graph is always going to have positive slopes. So right away, even if we don't have any numbers to go with these, you should see the left side is negative, the right side is positive, so the slope is not constant. The slope is changing. It's also changing as a definition because it's a curve. If the slope was constant, then everywhere on the line you'd have the same slope. But look at this. This one is a different steepness than this one. Okay? So the slope is always changing. If the slope is always changing, it makes a difference where you calculate the slope. Hence, we only want to do it with 1 point. If you do it with 2 points, it's inaccurate. It's an average of what the slope is through here. I want to be able to do it with 1 point, and that's where we're going with it. Okay? That's what this formula is going to do for you. It's going to allow you to calculate slope at 1 point. This definition works great when you have 2 points that you're working with. This is what works if you only have 1 point. Okay? So we need to progress past this definition to work with a fancier one. All right? This first piece of information that's right here is something you don't do until 4th quarter in pre-calc. Okay? So we're not going to get to this piece right here, but we are going to work with this. Okay? I think it's really important especially for everyone that's going on into pre-calc, that you understand what this is, so when you get to pre-calc, all you need to learn that's new is what this piece of notation is right here. Okay? Even if you're not going on to pre-calc, the reason that we're going to work with this is because we're working with function notation, this f of x stuff. And this is a great application for when is this used? Well, you use it to find slope. That's one application of it. Okay? So that's the other reason we're doing it. First thing I want to do is convince you that this thing is finding slope. So I want to do it first with a line. You guys should remember y equals mx plus b. This thing is your y-intercept. This thing is your slope. So we don't need this fancy formula to tell us what the slope of this line is. The slope of this line is 3. Okay? But I want to convince you that it actually works. Okay? As we've been working with, y is just another name for f of x, or f of x is another name for y, whichever way you want to go with it. That these two things are interchangeable. As we've been working with the function notation, f of x, well, there's an f of x, here's an f of x plus h. Okay, this is the formula I want to use with this. The best advice I can give you when doing these is write the function first without the variable, put a parenthesis wherever the variable is. I need to give myself a little more room there, sorry about that. Put a parenthesis wherever the variable is. So this is that formula. Okay? I want to find out what f of x plus h is. So I put in an x plus h wherever I put that parenthesis. Then you go back and you simplify the right side. So 3x plus 3h minus 2. That is this much right here. Then I'm supposed to take this and subtract f of x from it. Well, this is f of x. So I need to subtract f of x from this. And I should get rid of that so you guys don't think it's a fraction. Whoops. Okay, my eraser symbol was a little bigger than I thought. Let me rewrite it. 3x plus 3h minus 2. From that, I need to subtract the original function, f of x. So I need to subtract 3x minus 2. I need to take the parentheses off. So I got 3x plus 3h minus 2. All I did was rewrite it and distribute that in. Minus 3x plus 2. 3x cancels with 3x, and the 2 cancels with the 2. So I'm left with 3h. That is the entire top of this equation. What you just found was the top. F of x plus h minus f of x gave me 3h. Now I need to divide by h, which gives me 3, which, like I said, we already knew that was the slope. And so I'm just proving to you that this actually does find slope. Okay? When you're doing equations that aren't lines, you're going to see this a lot, and I'll show you where it's going to creep up. Okay? So you need to be good at it. We need to get efficient at it. So x plus h squared is not, you can't distribute this in. It's not x squared plus h squared. It doesn't work. So I'll prove it to you that it doesn't. You know that 2 plus 3 is 5. 5 squared is 25. If you distribute this in, you get 2 squared plus 3 squared is 4 plus 9, which isn't 25. So you can't distribute this in. What are you supposed to do here then? Well, you're supposed to FOIL it. When you FOIL that, you get x squared plus xh plus xh plus the last h squared. You get 2 xh's. So you get x squared plus 2xh plus h squared. So when you guys see x plus h squared, remember that it's going to be x squared plus 2xh plus h squared. You're going to see it a lot. If you have to stop and multiply this thing out every single time, you're going to drive yourself crazy. Okay? So if you just get used to that's what this is worth, you're going to be much more efficient at doing these problems. Okay? I'll show you another way to get that answer. If you have x something squared like this, the shortcut is you square the first thing, multiply these together, and double it, 2xh. Square the last thing, h squared. Okay, that's a shortcut for it. Or just memorize it, whichever way you want to do it. But don't recalculate this thing every single time. You're going to find this pattern, f of x plus h minus f of x all over h. All right? The first thing you're going to do is calculate this piece of it. So you're going to do this in stages. When I'm given these problems, you guys, I don't calculate the thing all at once. I do it in pieces. So I'm not giving you any advice that I don't do myself. The first piece of advice I'm giving you is write your function first without the variable. So I'm using this now. Squared minus 2. And in that spot, you're going to fill x plus h. Because I want f of x plus h. I want f of x plus h. So this is where I put it. That's the recipe. F of something is 3 times something squared minus 2. Well, f of something, I don't want f of just any old thing. I want it of x plus h. So you're putting an x plus h in that spot. And I'm serious. The best advice I can give you guys is write the function without the variable, parenthesis in place of the variable. If you heed this advice, you will do so much better on these than if you're like, I hear what he's saying, but I'm going to do it my own way. I'm serious, guys. Follow this advice, and you will do it much better. Okay? All right, I said you need to practice what this thing was, and there it is. So it's 3 times this stuff. X squared plus 2xh plus h squared, minus 2. All I did was expand this. The 3 has to multiply in. Minus 2. Now all you did was calculate this first piece. I now have to subtract the original function from it. I now have to subtract f of x. So I'm going to subtract the original function. Whoops, I scrolled it down so you can't see it. 3x squared minus 2. So I write 3x squared minus 2. I'm now doing this piece. I'm subtracting the original function. Distribute the subtraction through, and now collect like terms. 3x squared cancels with 3x squared, minus 2 cancels with plus 2, and you're left with 6xh plus 3h squared. Now you have to divide it by h. Okay? And we've been practicing this idea for a while now. You can't just cancel it in one spot. You have to cancel it in both. If it helps you to split it to help you see what you get, which is then 6h, because this cancels, and this reduces, plus 3h. This is your final answer. Okay? If you have this one, the advice I gave you, okay, so this is the whole pattern that you're going to use, is do this piece first. Don't try and write the whole thing. Write the function without the variable, parenthesis in place of the variable, so I guess I put another one, minus 2 squared in this spot. So I put a parenthesis here. In this spot, you're going to put x minus h. Okay? So now I got 3x minus h minus 2 squared. Okay, this depends on how you guys want to multiply it out. Do you guys want to draw a lattice and multiply it out? Do you guys want to draw the distributive property? So x minus h minus 2 times x minus h minus 2 and do the distributive property and multiply it out. If it was me, I would draw a box and multiply the thing out. Okay, that's me. Okay, because I tend to lose pieces of information, so I know my limitations, so I'm going to write this out. If you don't like doing it this way, don't do it this way. Do the distributive property and multiply the thing out. You cannot use FOIL on this one. Okay, you can't do it. So this goes x squared minus xh minus 2x. Then you've got minus xh. The order really isn't important. H squared 2h. Then this would be minus 2x. That would be 2h. And then that would be 4. Now you collect like terms. So you've got 3. That 3 is still out front. So I've got an x squared. That looks like a minus 2xh. Then I've got, so this is gone, this is gone, this was gone, a minus 4x. So this is gone, this is gone. Oops, and that's gone. I don't know why I canceled that one out. I apologize, I hit the wrong thing. So I have 4h, sorry about that. Now both of those gone, plus 4. Now I have to run the 3 through. 3x squared minus 6xh minus 12x plus 12h plus 12. Okay. Now I have to subtract the original function from it. So I have to subtract minus 3x minus 2 squared. I have to expand that. There's no nice way about it. Okay. So minus 3 x minus 2 squared. And I showed you guys a shortcut for this. You square the first thing, multiply it together, and double it. Square the last thing. Now it's all times negative 3. So minus 3x squared plus 12x minus 12. That's this. I have to subtract all that from it. So I've got the subtraction symbol already there. So I'm going to have a minus 3x squared plus 12x minus 12. Combine like terms. I know it's getting long. This is what you're left with. Wait, didn't I have an h? There's an h squared. I forgot an h squared. Whew. I forgot a term. Okay. So this, and this are what's left. So I've got minus 6xh plus 12h plus h squared. I know it's getting messy. All over h. And then you cancel an h out of each of these. So I have minus 6x plus 12 plus h. And that's going to be your final answer. Okay. One of the reasons I've been pushing you guys to show your work as you do this is because of stuff like this. You can't possibly see this answer. And if you don't have a way to logically organize your work, you're going to stumble. Okay. So I really need to push you guys on being able to show your work. So this next one, same formula, f of x minus h, there we go, plus h, minus f of x over h. Write your function first without the variable, parenthesis in place of the variable. Now fill in x plus h, wherever that spot was. There you go. There's nothing that simplifies here. Now I have to subtract the original function. Minus 3 square roots of x minus 2. Take the parens off. And so what I've got, I'm going to rewrite this first piece. 3 square roots x plus h minus 2 minus 3 square roots of x plus 2. The only thing that's going to cancel are those two. 3 x plus h minus 3 square roots of x. These cannot combine. It's kind of like saying 3 square roots of 6 minus 3 square roots of 2. I can't bring those together. If you were multiplying, you could bring them together, but not when you're adding and subtracting. So it turns out that's as good as it gets. over h. So ones with square roots, you may initially go, oh, this is going to be awful. No, it's actually a lot easier. Okay, so you're finished. That's done. Okay, I know this is all new and this is a little bit daunting, but trust me, you guys will be just fine.